To introduce Roy Sykes, who will be your moderator this morning.
What a luminous panel, eh? Okay, panel?
Glow in the dark.
One, rotate. I'm sorry.
After dinner game at one of the conferences.
The year was 1960. Transistors were the size of pencil erasers, and a 10-transistor radio was a popular gift item. Media still referred to computers as electronic brains. The state of the art in computer memory consisted of rotating drums and magnetic bagels strung together. APL did not exist. Neither did BASIC or Fortran or COBOL.
Fortran existed.
Sperry Univac Corporation was locked with the International Business Machines Corporation, and they were waging a mighty struggle for dominance in the very rapidly growing field of computing. Most notably, none of those in front of you had gray hair. Most had not yet met. But one, Ken Iverson, a professor frustrated by his inability to concisely describe the workings of these machines to his students at Harvard, invented his own notation. As yet unnamed, that notation began to cause some excitement, cause people to think. In its race with Sperry Univac, the International Business Machines Corporation decided to hire that young professor, seeing promise in both him and his notation. Shortly thereafter, he met a genteel fellow by the name of Volkoff. The seed, incubated for a decade in one man's mind, was ready to send forth shoots. The next thing that happened, as a matter of fact, Aidan, why don't you tell the next thing that happened?
What, is there a microphone that we can wear? Well, actually, I'll have to go back to say the prior thing that happened. The prior thing that happened is that Ken and I found ourselves working for the same man in IBM Research, a man by the name of Lyle Johnson, who I believe had received his computer training, or some of it, under Grace Murray Hopper. And among the things that Lyle taught me, and he was my first mentor in this business, was always ask the customers what they want and then don't pay any attention to it. And that's how we designed APL. Since the advertisement for this session said that it was going to be a perspective, it just so happens that I have recently done something along the lines of perspective, and I wrote a paper. There's going to be a special issue of the IBM Systems Journal this fall on APL, and I wrote a paper for that called the IBM Family of APL Systems. Now, this is obviously somewhat parochial, since I deliberately and specifically dealt only with the IBM systems. However, I give a great deal of credit in general, as you know, to the other work that was done. Burroughs, Jim Ryan, and company, for example, were very early in developing their own system. However, it is still the case that a great deal of the work was done in IBM, and so looking at these IBM systems will give you some kind of perspective, and you can add in from your own knowledge some of the things that happen in the outside world, as it were. I will do this rather quickly. This diagram was not prepared as a foil. It was really prepared to be printed, and so it's probably not the best. But there you see the very first glimmer was PAT, the personalized array translator, which Herb Hellerman produced for the 1620. And that acted as somewhat of an inspiration in several ways. It showed that it was possible to implement an array language, and it gave some hope to being able to teach students on machines that were not so oppressively large that they could in fact fit into a classroom. Then in 1965, Larry Breed and Phil Abrams started to work on something which became IVSys, while some people out in California were working on I'm not sure what the M stands for, MAT 1500. 1500 was an educational system, so the roots of APL in education were quite deep. LC, there's a lot of interesting stuff here which I can't really go into right now. As I say, I want to give you a perspective. One way to look at it is to look at this column. And this column kind of starts with APL 360, basically, after IVSys. And the code survives down here. A lot of the APL 360 code goes right down through the end APL SV. Early on, somebody in the Cambridge Scientific Center decided to put APL on CMS. And in Palo Alto Scientific Center, they started working on microcode. And back in research, we did the APL for the 1130 and so forth. And here we see, look, giving you the whole thing there. It's a little bit messy, but not entirely intolerable. If you look down the middle column, you see the evolution of VSAPL, and the second column over here is the heritage of APL2, which you can see actually started quite far back in '73 in the Philadelphia Scientific Center, and earlier, in fact. We talked about some of the ideas for that. And then when a full-fledged development group was put in place here in California, and the VSAPL merged with APL-SV, and we got APL2. Over here, we see those are kind of big machines. Over here, we have smaller machines. And it's not generally known, I think, that the first personal computer was an APL machine. It was indeed built to be an APL machine, and that, in fact, was an inspiration due to John McPherson, who figures in the background of all of this. You don't see his name in the literature, but he was there. He was there. He early understood the value of the APL work, the value of Ken's ideas. He supported us in the sense of having us give courses at the Systems Research Institute, of which he was the head, and was always there with technical ideas, suggestions, and some influence in the higher part of the corporation. But in any case, the 5100 came from this SCAMP, and the A there stands for APL. And some of you may know that the PC, actually, the IBM number of the PC is 5151. So APL, aside from the fact that modern PC systems depend to a great extent on the user interfaces, have borrowed a great deal from the early work that we did in APL and the applications that people wrote for APL. The actual hardware owes its provenance to APL. And over here we have the work that was done primarily at the Madrid Scientific Center and later Winchester, putting APL on the smaller machines, the PC. And this last one is something that didn't work out too well, but some of the ideas came in. So that, if you now can fuse that with your knowledge of what was going on in the outside world, the work at Scientific Time Sharing, the work at IP Sharp, the work at Burroughs and other manufacturers, you can get something of a perspective on APL over the years. I have a few small remarks I might make in addition. I mentioned Lyle Johnson, and Herb is here, and John McPherson is here. Another name that is never heard is the name of Henry Ernst, who was the higher level manager of the particular group in the IBM research when we did the implementation. And we owe a great deal to him. Larry probably can speak to that better than I can. But I remember that Henry said, what you have may be okay, but unless it's reliable, unless you can really depend on it, I'm not going to let you, go ahead and offer it to people. So he insisted on a quality standard, which turned out to be extremely important. I think I'll stop there. I have a few anecdotes, but others may have them as well. And maybe I'll get a chance before we're over to speak again.
By now it was around 1962, and APL still did not exist, although there was a book called A Programming Language just published. This furthered the excitement, expanded the word of this new notation that Dr. Iverson had invented. Perhaps the next interesting thing that happened had nothing to do with APL. It was an implementation of a language similar to APL, perhaps, called PAL, PAT, the Personal Array Translator. And the person who wrote that implementation is here on the panel, Herb Hellerman.
Okay, if it's okay, I'll speak from here. Is that okay?
Sure.
Yeah, rather than... My earliest encounter with the APL phenomenon, if I can call it that, happened, as Aidan reminded me, even before there was an APL, was when I met Ken Iverson in about 1960 at the IBM Research Center at Yorktown Heights. My main job there at IBM was as a researcher and later manager of a group working in what was called machine organization, but it would now be called computer architecture. An APL was a powerful new tool for precisely describing computer architectures. And we demonstrated this with several internal IBM reports describing architectures of the day, especially things like the Burroughs B5000, the wonderful new stack machine that was going to revolutionize the world, but didn't, and several other architectures of the time. Remember, at the time, the language was only a paper one, since there was no interpreter or compiler. It was evolving. although it definitely reached the solidification point with the publication of Ken's book. I believe the date on that is 1962, when the book came out. And that level of the language was used in the famous and excellent article in the IBM Systems Journal by Iverson, Falkoff, and Sussenguth in 1964 that precisely described every single instruction and much of the rest of the architecture of the IBM System 360 that had just been announced. My own book, Digital Computer System Principles, published by McGraw-Hill in 1967, used the same level of the language to describe many hardware and software algorithms, thereby providing a unifying influence to these two subjects within two covers. As you can see, I was definitely sold and very enthusiastic, and remain so to this day. By 1963 or so, I became interested in producing a computer implementation or translator for the language. In fact, and Ken can contradict me, he often does, but my recollection of the day was in 1963 that I was more interested in a translator than he was, since his main interest seemed to be in using the notation and language for human communications and for use by scientists in the mathematical community. But I was after a translator, and I tried to interest people in IBM to write one, since I didn't have the skill, nor did the people under me in the machine organization group have the skill to write a translator. We tried in many approaches, didn't have much success, until the IBM Computer Center committed part-time of one programmer, a gentleman by the name of Joe Harry. That's another name that sort of has disappeared in the midst. But Joe Harry worked for several months on a compiler for APL, what would be the first compiler. He even had part of it working, but it never was finished, and IBM management, in its great wisdom, pulled him off the project to work on something else, and nothing ever came of that effort. In about 1963, I decided to take matters into my own hands, and I proposed that I write an APL implementation. I strongly argued and felt at that time that APL was especially suitable for personal computing. Why did I think this? It was because of its array orientation allowed the programmer user to specify more work with fewer keystrokes than any other language, and also because the same user could think faster and better with APL paradigms than with those of other languages. And these traits were especially important in personal computing. These things may sound obvious today, but I would submit that in those days they were somewhat less so. Given the limited resources, which was just me, and rather ignorant of software systems, I decided to confine the project to a single-user personal system, confident that when APL suitability to personal computing was demonstrated that way, it would we could later do a multi-user time-shared system that would be economically feasible. IBM Research agreed to these terms, and I was given sole use of a Model 1620 computer, IBM's small scientific computer of that time, which was about desk-sized. The keyboard was a 1620's console selectric typewriter. The computer had 20,000 digits of memory, about 10 kbytes, and a card reader punch. Later on, it was upgraded to 40,000 digits, a wondrous increase, and a disk drive was added. As for the language, I started with Ken's book, but quickly suggested some improvements. The major one was to throw away the clumsy epsilon notation so that a scalar taken with a vector or matrix with any operator would automatically apply to every element of the vector or matrix without the need to multiply the scalar by an all-ones epsilon array as the language then required. My implementation was called PAT, short for Personalized Array Translator. It had two major and really terrible limitations. First of all, it was only a small subset of APL. And secondly, and probably more important, only one operator was allowed per statement. There were no expressions. These limitations were largely due to my own limitations in what I understood about software at the time. The PAT system, however, was used rather intensively and enthusiastically by some scientists at IBM Research during the period 1964 to 1966 approximately. A batch version of PAT was produced for the 7090 by a gentleman by the name of Lyle Heath, and some people used that. And a paper was published in the ACM Communications in 1964. Perhaps PAT's main influence on APL was that Ken Iverson started to play with it. Although he was not happy with its limitations, to say the least, he had a chance for the first time to see a live system using language and observe its effects on people. He was teaching an off-hours high school class at the time, and I remember him bringing the students to the lab to run their programs on the 1620 PAT system. On one such occasion, he brought a visitor, a young man named Larry Breed, who, as I recall, was a Stanford student, or I'm not sure, undergraduate or graduate. He'll clarify that in a minute, perhaps, who spent several hours with us. As it turned out, that was the beginning of a whole new major chapter in the APL history. Just briefly, since that time, I left IBM in 1969 with my APL enthusiasm intact to design a new professionally oriented graduate program at the State University of New York at Binghamton. It was and is a mainly liberal arts college. APL was selected as the program's first programming language. Students from many disciplines discovered computing via APL on the excellent campus time-sharing system that had in the meantime been developed at IBM by Breed, Lathwell, and Moore. Some students thereby found their life work as computer professionals, and I attribute this in part to the stimulation of APL in their early computer encounters. My own involvement with APL in those days included a second edition of my book, Digital Computer System Principles, published in 1973, that used the implemented and now familiar APL language rather than the earlier language version, and also a 1976 book, APL 360 in Applications, which was essentially from the notes of the text we used at Binghamton. Although my work in the past several years, which is strategic planning at the Amdahl Corporation, does not involve programming, I'll always look back on APL with very warm feelings, not only because of my personal involvement with its development, but also because of its almost magical effects on many people, especially young people. That's what I have for now.
There were other people involved in the early development, as you've heard alluded to by the first two panelists, who aren't here, either because they couldn't come or because, in some cases, because of death. One of them, John Lawrence, is another invisible name, but he was the one who was instrumental in getting IBM its first wide public exposure. Namely, he was, I believe, the editor of the IBM Systems Journal at the time, that a 4-page description of the IBM System 360 was published in APL. The next person I'd like to introduce you to is a person few people here know. Everybody up here knows. John McPherson was a manager. And surprisingly enough, we need them. Those are the... John McPherson, perhaps more than any other person, was the envelope which carried this whole group of writhing people and brains and ideas out into a commercial reality, out into APL 360. John, will you say a few words to us about those times?
Before I start, I want to ask, is this microphone working so everybody can hear what's said from up here? I had real trouble when I was in the audience most of this week, and I don't want to either speak too rapidly or too long. Okay. My interest in APL arose from essentially my job of helping run the first IBM Systems Research Institute in New York at the time when we were first wondering or realizing that our people helping customers in the field would have a problem in helping people make full use of the equipment then becoming available as the electronics took over the field we all know now. As a result of that, in that position, I've had the good fortune to have Ken Iverson come in to teach one of the courses in our first Systems Research Institute, and have Aidan come down for many courses thereafter to teach other ways of IBM systems engineers what the business of being a system engineer was and how to do it. As a result, this was a matter of continuing interest to me and has been ever since. This was, of course, this was at the heart of the things I felt IBM wanted to do, namely to help other people make better use of computers. And to my mind, APL still represents the ideal way for people who don't know anything about computers to get some of the benefits of the computer. And from that standpoint, I'm just delighted to be a part of this group and to have continued my interest in education and in the use of APL or growth of IPL, which I hope will continue for a long time.
Unlike most managers, John is clearly a man of few words. The next step, I would say, was implementation. Implementations started with a prototypical personalized array translator. The next thing that was done was here at Stanford. The scene shifts across the country now. Somebody who could not be here, Phil Abrams, wrote as his doctoral thesis a thesis called An APL Machine, which describes an ideal and as yet so far unimplemented pair of machines which would implement APL. Very soon thereafter,
Hold on.
what?
Phil's thesis was in '69.
Was it 69? He worked with you.
I don't want to spoil your story.
Okay. Okay, my story has been spoiled, though. The thesis was published in '69, but before that, Phil worked with Larry Breed, on implementing an advanced form, if you will, of the personalized translator, this one using punched cards and written in Fortran. It truly was the first implementation that we might recognize as APL. Let me have introduced Larry Breed to tell you more about it.
I would like to talk about Stanford's connections and contributions to APL. They go farther back than most people realize. In about 1959 or 60, George Forsyth was getting excited about computers, and within the math department here, beginning to create a computer science department. It was largely his enthusiasm as the head of the computer science part of the math department that got me and Roger involved. I I recall that in '62, he invited, or he urged, he took his broom and shooed all the students out to a seminar. Heads of departments have to do a lot of that, but he shooed everyone out to a seminar where over at SRI, some fellow named Iverson was talking about something, and Roger and I were in the audience, and Ken was talking about his new book and what you could do with the notation there. A lot of it went over my head, but I recall Roger muttering for days after about what a wonderful language this would be for expressing matrix algorithms, and what a great way what a good language for implementing really efficient execution of matrix operations. But that was sort of a one-time event, and it just sat there for a while. I had introduced Roger to computing at Stanford when there was a 650 here, and they just brought in the giant Burroughs 220. It had 5,000 words of decimal memory, had a 200 microsecond add time, which was damn fast. For a short while, Roger was groping through the initial concepts of working with computers. I'd been in the field already for 3 or 4 months, and so I was clearly senior, knew a lot more than he did. It wasn't too long after that with IBM bringing in a 7090 for Stanford and George Forsythe encouraging work on an ALGOL compiler for the 7090 that matched the compiler we had for the 220. Roger was in the heart of building that compiler, and I and the others on the team that were doing that, we did our part, but mostly we just struggled to keep up with the true genius that Roger was putting into the development of his part of the compiler. He was creating control structures that have not been seen since or before. They're remarkable stuff. George Forsythe was a seminal influence on many of us. John McCarthy, he brought John McCarthy here, and McCarthy brought with him not only Lisp, but he brought a PDP-1 and a time-sharing system that let people program in assembly language and use a text editor, but it ran on a machine with a few kilobytes of memory and a drum, and it time-shared. It swapped in 4K of memory, gave you a slot to do some programming in, and then swapped it out and swapped in someone else's. And it was largely that model that Roger and I based the APL time-sharing on when we finally got to research. Mike Montalbano was an enthusiastic IBMer and Iverson notation user in the early days, who was here at Stanford giving classes in the biz school using Iverson notation. He gave a seminar that I attended, renewed my interest, and later when Ken came through to talk about his formal description of System 360, it was Mike that introduced me to Ken. Someone else that George Forsythe brought in as a guest professor for a year was Gene Amdahl. Amdahl was IBM's lead architect on the 360. He was at Stanford in 64 to 65, and Phil Abrams, who I had just met, Phil and I spent the year camping in Gene Amdahl's office and learning so much about machine architecture and introducing him to Iverson notation. Remarkably enough, the same System Journal issue that had the formal description of System 360 also had Amdahl's article on the 360 architecture. Amdahl had never heard of Iverson notation and was surprised and gratified to find this arcane notation being used to describe the architecture of his baby. There was warmth with Amdahl and us that persisted for many years, and in fact, well, about 10 years later, I got in contact with Amdahl again when he had started his new company, and partly as a result of that and Gene's feelings about APL, Scientific Time Sharing was the recipient of the first commercially installed Amdahl 470 as its mainframe. Well, I went to Yorktown in the middle of '65. As Herb told you during my interview session there, I got to play with Pat. I wrote a program to translate an arithmetic expression to Polish notation. By the way, I implemented the stack with something like S equals 1 shift of S. You've got a bug there. It overwrites S. So you might want to fix that. It was a fascinating time in Ken's group. We were just moving from its being a paper language to being a language that was being implemented. And there were struggles to understand what this really meant. One thing it certainly meant was leaving the freedom of notation you could write anywhere on a blackboard to something that had to be enterable on a computer linearly. This limitation in your type fonts. The language had only two-dimensional arrays up to then. There was a kludge to provide a family of two-dimensional arrays in the formal description, but basically it was 2D arrays. There was a mu and nu, two functions to give you the row length and the column length, or vice versa. Row was a brand new function that I'd never seen before that Ken and Aidan had come up with in the months previously to work with multidimensional arrays. We didn't understand what the shape of a scalar was. I remember an argument with Ken and Aidan and me over the shape of a scalar. Yeah, we couldn't agree on something as fundamental as that. Certainly something as complicated as scalar extension we wrestled with for a long time. That is, should a one-dimensional array scalar extend? Should a one-dimensional vector extend? Well, rho v, the shape of v, is not a scalar. Can you say v divided by 1 rho v? Don't know. We were struggling with the aspects of interacting with a computer user and what it meant to have error messages, input and output. None of this was explored yet. At that time, functions were not defined with a del. They were you knew f was a function because it was f in a different typeface. We used f overstruck with a wiggly underscore, wiggly overscore. That key was later replaced by a del symbol, and now we have the del editor. Something else going on at the same time was that IBM as a whole seemed to be afraid of time sharing. It was new, it was not batch processing. There were a few one-off machines that did time sharing. And I remember a visitor telling Ken and us with some heat that it was wrong to give back the kind of response time that APL could give people. The system that he was proprietor of automatically built in a 5-second delay on every input before it would print anything back, because he said that kind of fast response frightens users. So, grasp, if you can, what the environment was like. This was all brand new stuff, and no one really had a clear idea of what time sharing or APL ought to look like. Henry Ernst was mentioned. One of the important things that Henry did for us, in my view, was that when I thought of bringing in someone from outside IBM to help on the implementation, the one person I knew was deeply interested was Roger Moore at IP Sharp Associates. Henry put up the money to bring Roger down, a short-term consulting arrangement. Sometime later, I had to inform Henry that we'd kept Roger there longer than we'd expected. I'd overrun by about $5,000, the amount of money that we had budgeted, and Henry sighed and said, okay, I'll cover it. But it was little things like that that kind of support at mini level made the difference sometimes between APL making it out or not making it out. One of the common threads in that whole period was a tension between the language creators and the implementers. Ken and Aidan were creating the language. Ken certainly was the genius behind the language, and the rest of us, I think, tried to outdo each other in being conservative about what went into the language. The implementers as much as anyone. I'll give you 3 examples of ideas that came up that the implementers resisted and to some extent refused to implement because they just seemed wrong to us. One that was being proposed early on was that we get rid of the and or symbol and use min and max. And something was wrong with that, and what it turned out to be, of course, was that they don't have the same identity elements. But we knew early on when APL 360 was going that people needed trig functions, sine, cosine, and so forth. Ken said, let's use monadic less than and equal as sine and cosine. Dick laughed when I thought that was a horrible idea, and we didn't put it in. And that fortunately gave us the grace time for Eugene to come up with the wonderful notion of circular functions. A third one was Aidan's notion that we could leave the commas out between numbers and we would have vector numeric constants. Dick and I knew that there was something wrong with the syntax there, and again, we refused to implement it. And it took some number of weeks before we admitted that we were wrong, and we did in fact install the vector constants that now are it's hard to look back and imagine there could ever have been any controversy about something as straightforward as a vector constant. Another common thread back then was the arguments. Ken Iverson loves arguments. I think I got hired by arguing with him. I recall once in the 65, 66, when John McCarthy came to visit research, and he visited Ken's group, and Phil Abrams and I were there watching while Ken was showing John McCarthy, I think, IVSys, the one written in Fortran that ran on some primitive time-sharing equipment. And they were arguing about languages and language principles, and I think it was something like this. It's important to have a uniform representation for the elementary objects in your language and a uniform way of creating the structure to hold these elements. It's important to have a way to map a function to apply to all the elements of a structure. And they were each saying things like this in their own words and getting angry. And Phil and I were watching in amazement, seeing them saying exactly the same thing to each other and disagreeing violently. But arguments, blackboard arguments that echoed down the hall were characteristic of the group and one of the exciting things about working there. And because that was so much the mode, I, for a while, kind of overlooked a quiet, soft-spoken person who did not really get into these loud arguments. His name was Gene McDonnell. He started working, when I became aware of him, he was working up the road on the project that later became the 360 and 370 time sharing with the virtual hardware and so forth. When I didn't know who he was making the way smooth for us to get the IVSys onto the experimental 7090 with paging hardware. Later he found disks for us that let us continue to run and do development on our Model 50 when there was a disk famine and there was no storage to be had. Later, in conversations with him, I was delighted to discover that this was not just a computer nerd. This was someone with a classical background who would come in saying, you know, do you realize that APL is the Greek root that means simple and not yet fully formed? He was a wonderful tempering influence on the group, and someone who loved amateur mathematics in the way that I did. The kind of math that isn't real math to a mathematician, but it's the fun stuff. It's playing with the golden mean. We spent evenings at a terminal trying out, let's see what happens with, well, the name for it is phi, the 1.61 something. Yeah, you can get a lot of different ways through the Fibonacci series and so forth. But let's try, you know, phi, bang, phi, shriek, phi. You know, let's try, you know, all combinations of APL functions and see what happens. And marvelous patterns coming up. And I remember his being just as surprised and gratified as I was. And later doing so much to merge APL with the delightful part of mathematics. All in all, Yorktown in those days was the most exhilarating environment that I've ever worked in. I feel in a way that I started my professional career at the top, going to work for Ken and getting to work on this project. It was wonderful fun, and I'm very glad to be part of it.
Well, Larry introduced Eugene McDonald better than I could, but I would like to say one thing about Eugene. In the early 60s, Eugene was a time-sharing salesman. And perhaps he's the only one up here who can represent anything about sales, being that Al Rose is not here. In any case, to us, Eugene probably contributed more functions in less symbols than anybody on the panel. So please welcome Eugene McDonald.
Thank you. In the year 1300, Dante Alighieri was 35 years old. In the year 1961, when I first saw Iverson notation, I was 35. Dante wrote the Divine Comedy as a result of some experiences he had in the year 1300, and I've been writing about APL ever since I was exposed to it in 1961. The first time I saw it was very shortly after I joined IBM, and I saw someone reading some, I think the process is called hectography, some hectographed pages. These are the sort of things your grade school kids bring home that the teacher has duplicated with a sort of a purple ink. And looking at this, I was intrigued by what it represented without being able to understand any of it. But it looked to me as if it should be something that had some material substance to it. And this turned out to be some draft notes that the fellow had received when he attended a course given at the Systems Research Institute that John McPherson was talking about, a course that had been taught by Ken Iverson. So I found this congenial, and one of the reasons I found it congenial was that I had been programming for a while already. So I had come to IBM with a background in computer programming. And I had developed certain practices, styles of writing flowcharts and such that to me were congenial. I had been in a business area of programming, developing payroll systems and that sort of thing, though I don't have a background in accounting or anything of that sort. And I had come to the conclusion that there was some fundamental thing in the business data processing that I had been exposed to that was mathematical in nature that the accountants I worked with had no conception of. And it was the kind of thing that I developed for my own use, which is a sort of a semi-mathematical notation, found an almost exact correspondence in these hectograph notes. I was working for a man named John Coombs in IBM in White Plains. John gave me the charter once of looking through all of the research projects that were underway in the Yorktown Heights Research Laboratory, Yorktown Heights. See if I could find anything that had some relevance, some bearing on the educational projects that he was interested in getting me going on. And I found one in particular and said, this sounds interesting as if it might have some relevance. It was called Machine Descriptions. I said, could you tell me anything about this, John? What is this? He said, that's a couple of guys up at research who are trying to describe machines in a new notation. This was another connection I found with that hectograph pages. This is still 1961. I eventually found out the names of the people who were involved with that, the hectograph pages and the machine description. And one evening in September of 1962, I attended a voluntary education course, the first session of which in Kitchewan, New York, the research laboratory. And sitting there waiting for the teacher to show up with a handful of students, we were bursting the seams of the room that it was in. It was a very, very small room. In walks this chap and he looked around and said, we'll have to get a bigger classroom, and turned to the board and started writing on it and talking at the same time. And did that for an hour, it seemed to me, in retrospect. Probably he relaxed in between. I think we had a coffee break sometime. But this fellow turned into a two-handed talker because he was writing on the board, and he'd turn and give us some of his face, and then he'd start writing on the board again with his other hand. So that was something that kind of startled us. And
First the right, then the left?
I forget which it was, but it might well have been right to left, yes. That, of course, was Ken Iverson. And in a few weeks, we had moved to a bigger classroom. And one night, I think it was September 26th, and you can find in it, by the way, in the museum that we have here, there's a dog-eared copy of a book called A Programming Language. And if you could look inside, you see on the flyleaf the date. I think it's September 26, 1962. The box had just arrived from John Wiley and Sons in New York. Ken opened the box up and handed them out to us, and I was one of the lucky people to get a first copy of the first edition of A Programming Language. I might mention Howard Smith was also in that class. So his roots in APL go way, way back. But we shouldn't be talking about APL yet, because there was no APL. What I was doing in IBM was, after that education experience I had with John Coombs came to an end, I went to work for a man named Andy Kinslow, who had some ideas which were very close to ones that I had been expressing about using computers and communications. My background before I came to IBM was in communications, and I was very disappointed when I came to IBM to find out that their notion of a system was two boxes hung together by a cable. I was used to systems that were ganglions of nerve fibers spread over the entire continent, and I thought that one useful way to use computers was to connect teleprinters to them so that you could send things in and get results back. Andy Kinslow had the same idea, and he was the primary person responsible for this time-sharing system, which later became the host to IVSys, the first real implementation of an interactive time-sharing system. Kinslow, by the way, had attended one of the courses that Ken taught, and in later years he used to say, I was exposed to APL, but I didn't catch it. As you heard Roger say, Larry say earlier, I should say one other thing about Larry. I should have begun by thanking him for the nice things he said about me, and I want to tell you a story about something nice that was said about him by someone else, not me. I had come to Stanford in the early days of the TSS project, the successor to a 7090 project, and I gave a talk before John McCarthy's class of students about the design of this time-sharing system. And when the time came for the questions to be asked, one kind of surly-sounding young fellow asked me the question, why had I designed such a lousy floating point system for the 360 architecture? I hastened to disabuse this young man of my complicity in this affair altogether. And I can't, in all honesty, say who it was. I didn't know the identity of the fellow, but several years later, when I did in fact run across Larry, I found out that he had been in John McCarthy's class, and I suspect that he could well have been that snotty kid. Okay. But anyway, the batch system that they had turned into an interactive system, and it ran on this system that I had been working on designing. And I'll tell you some more about my contributions in that area. But my first reaction to this when I saw it, I sat down at a 1050 terminal and did some things with it, and I was aghast. This is terrible. What have they done to Iverson notation? Here they've done and created a complete new language that is completely different from Iverson notation. And they've just done a terrible thing. I don't have any choice in fonts. It has to be a typewriter font. And look at the way they do subscripting with those ugly brackets. This is just dreadful. And where are trees, for goodness sake? That was my first reaction. At the same time that I was getting my first exposure to this terminal, I was reading a copy of Computing Reviews, which had a review in it by Gene Samet, one of the progenitors of COBOL, which she was reviewing Ken's 1962 book. So 3 years after it was published, it was finally reviewed. And she said, it has some interest, but don't spend too much time on it because this is an unimplementable language. And this is at a time when I was using the first implementation of it. I gradually came to overcome my initial reaction to this terminal system called IVSys, which became APL, and had some warm feelings to it for quite a long period of time after that. I should say, my contribution to the APL 360 system when it came out is that the designers of APL 360 chose to use the exact same sign-off message that I had designed for the TSM project in the APL 360 project. So when you said right paren off, you got the how much accumulated CPU time and connection time you'd had to date and so forth. And that was my gift to you. I got to know Ken in that 1962 course, and I met him in the halls of the Mahansik laboratory where I worked one day, and I noticed he was carrying something, and I looked at it. It was a selectric printing element. I looked, and he said, "Oh, look at the characters on it." So I looked and said, "Oh my goodness, an Iverson ball!" And he looked at me and said, "It's an Iverson printing element." And I'm also responsible for having showed Ken his first 2741. We had advanced versions of these from Lexington, Kentucky in our laboratory. He hadn't seen one before, and his eyes lit up because he had only seen the 1050, which is bad as the 2741 eventually came to be in our minds. The 1050 was a lot worse. Okay, there's some history that is associated with the development of APL 360 that you may not have heard. I don't think you've heard from earlier speakers. And that is one of the very senior people in IBM had gone to a prep school. Arthur Watson or Dick Watson had gone to a prep school in New England, and I don't know if it's Hotchkiss. And they had been exposed to this brand new thing called BASIC, and General Electric computers were running BASIC, and terminals connected to this General Electric computer were there in Hotchkiss. And this apparently drove Dick Watson up the wall. And he went back to Armonk and said, "We have to have something like that to replace that, and soon." So they looked all over the corporation. They came up with a couple of candidates. One of them was QuickTran, sometimes called SlowTran. And that turned out to be not really much more than turning a terminal into a key punch. and that was thrown away. But then he was turned on to the Iverson group at research, and through his great influences, he was able to expedite the delivery of a Model 50 computer to them and also a 2702 communications controller. I think Larry's told about my contributions in lending equipment to these guys, so I won't go over that. One of the nice things about, the thing that really convinced me about the good qualities of the terminal system, which became APL when they put it on the 360, was the quality of the implementation. I think that the success of APL owes at least as much to the quality of that implementation as to the notation underlying it. I know that people in the early days of time sharing that Larry began to describe to you, the systems were terrible. They were just awful. They'd fail, and they'd give wrong answers, and they'd just do awful things to people. The APL 360 terminal system was the first really reliable time-sharing system that I had ever experienced, and I think that was the underlying reason for the reception of the Grace Murray Hopper Award by Larry and Dick and Roger when they received it in the 70s. I remember, I'm not sure if I saw this, I heard someone else tell me about it, how Roger Moore could stand next to the disk drive in the machine room and hear the thing clicking, click, 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 as the scheduler went over the disk drive surface and could tell you how many people were signed on. This is another thing that that APL computer was the first computer in IBM ever to run in the dark. It was required by company policy that no computer was ever to run in the absence of an operator. I think the APL system was the only one that ran without an operator. They turned the lights off in the room, so you'd walk by this ghostly lit room and see sparkling lights on the console, but nobody in it. And they had to get special permission, fight to get special permission to do that. Another celebrated event was one afternoon, sitting in the cafeteria at research, very lovely room, snow falling outside, deepening on the Taconic Parkway, and people were sort of expecting, when are they going to close it? When are they going to close it? Finally, an announcement came over. Because of the snowstorm and hazardous driving conditions, the laboratory is going to be closed. The APL system will continue running. Burst of applause. Okay. I had, as I say, been at Stanford early in the 1960s and given a talk on time sharing to them. And I met an IBM SE there who I later met when he visited our Mahansik laboratory doing this time sharing systems design. I'll call him by the name Goody Two Shoes because that's not his real name and I don't want to offend him. I asked Goody, did he know anything about some programmers that my friend Ken Iverson had hired that had been at Stanford? I said, well, who did he hire? I said, well, his name is Larry Breed. He just sliced it up. Larry Breed, he's the best programmer in the United States. So I said, well, that's consoling. And I was kind of worried about it because I knew that Larry I was going to try to set up a demonstration in somewhere in the Los Angeles area of this time-sharing system, and I'd wanted Ken to go out and do the demonstrating. And it turned out that Larry was in the area, and he commissioned Larry to do it. And I was kind of worried about this 25-year-old kid doing anything really significant. So Ken assured me that Larry was worth doing it, and I was immediately reassured by Goody about that. And he said, who's the other guy from Stanford? I said, his name is Roger Moore. Roger Moore? He's the best programmer in North America.
If Larry Breed was Mr. Interpreter, Roger Moore was Mr. Supervisor. The interpreter is the thing that executes the APL symbols that we see. The supervisor is the piece of software which deals with the operating system and decides when it can turn the, at that time, telephone or hardwired line around after a 6-space indent to let the other person talk. And perhaps Roger is more responsible for interacting with us every day in our usage of APL than anybody else. Roger, would you like to say a few words? And if he says no...
well, can you hear me from here? Yeah, I originally left the Black Balgol gang at Stanford to go up to Canada, where I wrote an Algol compiler, and then in 1966 rejoined Larry at research as a contract programmer. The purpose was to take this working Fortran version that was running on the 7093 TSM at Mahansik and move it 10 miles down the road to another machine. Now it seems simple. After all Fortrans are the same. And however, this experimental Fortran with its 21-bit virtual address space and things like that was missing continuation statements and a few other minor frills in Fortran. And there was also problems with the functionality of the operating system. The upper and lower case input from the terminal got mapped to a common case, which is what Fortran needs. The attention key didn't really work very well, and also the general system reliability was such that the time to compile one Fortran module was about the same as the mean free time between system failures. And save didn't really work either. So little delays in this porting project sort of led to Larry and I starting on the design of our own system, which wouldn't have to deal with those other people, and all we had to contend with was the hardware, which is perhaps simplification. So we just started on a scheduler design for a time-sharing system. In doing this, we were somewhat influenced by the JOS time-sharing system running on the Joniac computer at the RAND Corporation. That we didn't particularly like the language which they were executing, but the kind of service they wanted to give to the user sort of agreed with the model that Eugene was describing. That is, you had people out there looking at teleprinters, and there were 3 classes of user. There was somebody that was interacting with the system, that is, he was typing, getting short output, staring at it, typing more. There was somebody else who was output bound or printing wallpaper, and the 3rd class of user was someone who was compute bound. And these states came to us from a RAND Corporation, and the intent was to give fairly good service to the interactive user and to keep the printer running at full speed, and the compute-bound users get what's left over in the way of cycles. And so that was the design objective of the scheduler. Given that we had some design objectives, so we sketched some APL functions that would do this, and I'm told that over in the museum in Treseder you can actually see the original APL functions which described the system, and I think it would easily fit on one page, because there were really only 3 functions there. There was, given that you had users swapped into main store where they could be executed, there was a rule for picking one to execute and cutting them off after 100 milliseconds or something and letting someone else execute. A rule for deciding whether or not there was anyone out there on the swap disk who should be brought into store, and if so, selecting him to swap, or starting at the creation of an empty space in store. So there was a swap out scheduler which included a decision at least one user has to be brought in, and then given that the swap out had finally completed and that the disk channel was ready for another user, we could bring somebody in from the disk. And so there were really just 3 functions that we needed for the scheduler, and that was it. And so with APL, it wasn't very hard to describe these and analyze them and perhaps fix some of the bugs, and then these were transcribed to assembly language. We also had what are now known as device drivers to worry about. Because we looked at the IBM software that would particularly support the 2702 and concluded that it was of no value whatsoever, that perhaps IBM software has improved since that day, and some of it is of value. But so we made the decision to write our own complete standalone system. In the original APL system that was used to save one clean space was a true standalone system, that there was no operating system other than APL once it got going. And this created some problems with people who wanted to do other things with the machine. But why would anyone want to use a machine for anything but APL? So the disk was, I guess, the easier one. We were somewhat inspired by the PDP-1, I think, particularly more on the design of the disk I/O driver than for the scheduler in the PDP-1 system to which Larry alluded. It was more of a virtual machine concept than was the APL, where in the original APL there are all sorts of pieces of the machine to which you had no access. Your only I/O was through the terminal, whereas the PDP-1 system was more ambitious with regard to the I/O. But it did have a very fast mechanism for exchanging the user address space, and some of our analysis concluded that yes, we could get high transfer rates through the IBM hardware, that perhaps doing some things which maybe the software people might not have approved from, because the reason for the 36K workspace was that one cylinder of the IBM 2311 was about 36,000 bytes. And so we could read or write one cylinder in a spiral motion without any head motion. And so you could get fairly high transfer rates there. And this was an important thing in the performance. This also led to the workspace concept, which I guess was also, as Eugene pointed out, within the 7093 system. But we had started with what was intended as a mechanism for having some of the user's variables and functions out on disk, and while he was inactive, and then when you add a directory system to this and more disk drives, this becomes, you have right paren save and right paren load, and it's an easy way to give someone a way to hang on to their work. It's a little ugly, as anyone who's tried to implement right paren copy knows. Right paren copy is a difficult thing to implement, although we'd always realized it was an important tool for building on old work and moving your utility functions from one workspace to another. But the hardware, so that was a hardware artifact that I guess we still have. The workspace sizes have increased, and it's been a little awkward in some ways to swap a 16 megabyte workspace even with modern disk drive speeds. So perhaps that artifact, which still persists, it causes some problems today where the environment with virtual store and they are somewhat different. I guess the other artifact from that era of the hardware is the half-duplex nature of the terminals, that both the 1050 and particularly the 2741 were pretty much half-duplex. It is one side is allowed to transmit until such time as it decides to relinquish the line, and then we have line turnaround. And that's had heavy influences on the language. Things like AP1 and APL-SV sort of follow that model, and I don't know if we're ever going to get asynchronous input. The micro APL presentation gave some hint as to an alternative on the Macintosh, but it is an awkward thing to get around. That the response time was certainly something we were worried about. The interactive users, and both the concern about making the disk transfer go as fast as we could, such that I think in practice we could drive that technology at about 75% of its theoretical maximum speed for more than an hour. Perhaps the response time to the users wasn't very good, but we did move a lot of bytes over the channel in an hour, as we were in what might be called a thrash situation. We originally started with the 1050s, which were rather complicated terminals. I recommended them to anyone who repaired their own television set. But when we got the 2741, which was somewhat simpler and was willing to accept output from the computer, or even though it was not mechanically ready, our response time test was to clear all the mechanical tab stops in the 2741, push the tab key, and then 2, and then return. And if the system was working properly, the 2 would be printed while the carriage was still returning. This took about a second. In fact, you could almost do continued samples, and you had a nice recording of response time as the response to the 2 was printed back on the fly, and it was certainly good. The other hardware thing at that time was the Eugene wasn't quite right about figuring out IBM 23 just by ear. It took the Memorex 660, which had a cylinder address display, and if you looked at the max reduce of the cylinder address over about 1 minute, you could compute how many cylinders were in use for swapping, and in that day we had, I guess, 4 users per cylinder, so you divide by 4, and that gave you IBM 23. But
just count the legs and divide by 4.
Yes, exactly. Except I eventually left the Happy Frisbee gang at Research and went back to IP Sharp in Toronto, which I received a demo. I guess Ian had been visiting to see why I was spending so much time without generating all that much revenue down there, and he got a demonstration of APL from, I think it was Ken, and was so impressed he decided that IP Sharp should go into the time-sharing business. And so thus we left the official program supplier ranks, and then I became a mere user, and then it was important that we pressure IBM, and there were things such as the Share APL project, which existed to pressure IBM to do this, and Garth Foster was such a good man at leaning on IBM, and so I came to know him through there, and the APL project eventually matured and hived off as the quote quad, and he was, I guess, Ian had dealings with Garth. He was a very generous man, that he was selling subscriptions to APL Quote Quad at 2 a.m. in a Manhattan hotel bar. And so Ian purchased a subscription, and Garth was so happy to get another subscriber, he immediately used the money which Ian had given him from a subscription and bought Ian a drink. Well, with that,
there are 2 other people on the implementation team who aren't able to be here. I thought I should mention their names. Luther Woodrum, who's responsible for grade up and grade down, and Dick Lathwell, who ultimately became responsible for the design, I believe, of shared variables, certainly the implementation. As you heard Roger mention, Garth Foster came on the scene peddling copies of Quote Quad. Well, actually, before this, there was no SIG APL. In fact, there was no staple, the progenitor to SIG APL, and there was no Quote Quad. There was, however, Garth Foster, and he'll tell us about what happened.
I've been asked to try to give you a view of what happened in the user community, and I have to take you back, the only way I can do that is from personal experience. Take you back to the year 1966. I had just been hired by Syracuse University to be a research engineer on a contract that we had on time sharing with Rome Air Development Center at Griffiths Air Force Base. And I had sort of gotten into my work, and early in the fall, the project director came to me and said, "Oh, by the way, I'm going on leave in January. You're going to have to take over the liaison with this little side project we've got running with IBM Yorktown Heights, where we have access to an experimental time-sharing service called APL from a fellow by the name of Kenneth Iverson." So I was handed a copy of the 1962 book and the description of System 360 and set off to find out about it, and eventually we got one of the copies of the first user manual. Our sign-on was at Syracuse was 1052. They began at 1,000, so we were pretty early on. We had a 1052 terminal, which eventually Ken came in and saw the plastic overlay on it and told us about the 2741, which he obviously learned of from Gene McDonald. In 1967, I was out taking part in that contract to try to find out what time sharing was doing about communications command and control, and attended a conference in Cleveland, of all places, where there are some 35, 40 professionals gathered around talking about how computers could be used in communication command and control, and the big thing was Calvin Moore's track language, which could be implemented on a PDP-4, PDP-8 in less than 4K whoopee. There were only 2 people at that conference that knew APL. I sort of knew it, and I kept my mouth shut and let the other guy, who was Ken Iverson, talk to him. At that conference, one of the guys that, almost like a child, became so mesmerized with APL, he decided eventually to leave Western Electric and form a chain of interactive computer system companies called APL/Philadelphia Manhattan. It was Carl Korn. Subsequently, his company went bankrupt because he thought it should be treated even in those days as a utility. In 1969, Carl Korn called me back up again and said, "We're getting a project called the Interactive Systems Project, and we're going to have a subcommittee of that called the APL Committee. Would you attend, share?" And I went to share, and right away, my enthusiasm of justifying being there, I said, "Yes, I will put together a newsletter for you, and it will be called Share Raised to the Power of APL 360. And the newsletter first came out in early 1969. It was later in 1969 that the first users conference that Herb Hellerman spoke of took place at SUNY Binghamton. I went there. I had the local IBM salesman take me by hand almost and say, "I would like to have you meet Mr. McPherson." Now, I knew that Mr. McPherson was a pertinent person of importance because the salesman walked up to him sideways and genuflected. It was at that users conference that I was taken to the side along with Cyrus Creveling of NASA Goddard and Conrad Wogren of the University of Massachusetts, and it was decided that we would undertake establishing the next APL users conference, which would be in 1970 at Goddard's Space Flight Center. At that conference, I noticed that most of the attendees were IBM salesmen who were there to try to find out about selling APL 360, which had become IBM's first program product. There were people from other walks of life other than IBM who were interested in implementation and interested in use of APL, and so I was going around hounding out the share newsletter to them. Somehow that didn't seem wrong to me at the time. I got thinking about it afterwards, and I became so interested in the fact that they all wanted to talk about their APL implementations that I took up the courage and invited them to come to a conference center that Syracuse University has called the Minnowbrook Conference Center. And so the first APL Implementers Minnowbrook Conference was held in the fall of 1969. I was amazed at the large number of people that actually came from that invitation. In 1970, we had the Goddard Space Flight Center conference, and before that took place in the summer, a very interesting thing happened to me. That was that I had been on the phone several times with Larry Breed, who was then with STSC, trying to convince Larry that he ought to allow me to use Air Force money to buy a copy of the file system so it could be added to our APL 360 system so we could have files, all of the version that he was bringing out. Larry was reluctant to let us have the file system because we were using Air Force money. We were in the middle of the Vietnam War, and he had strong feelings about anything about APL being used that might further the military effort if he could avoid it. And so I assured him that we would take extreme steps to make sure that Rome Air Development Center never got their hands on this, and they didn't have any IBM computers at the time, so it was pretty safe in that regard, and that they wouldn't be able to use our system for anything in the terms of the military. And it was at the agreement from that, over an agreement arrived at over the telephone on good faith, that we got the STSC file system at Syracuse University. We went to Goddard, and by that time we'd had so many people outside of the SHARE project interested in the activity. Carl Korn, we'd been moved up in SHARE from establishment of a regular project called the APL project, but the powers that be in SHARE didn't want Carl Korn to run it, so they asked me to run it, and so it became at that point, and I figured it was too much to continue to try to edit with all the problems I was having with the APL Quote Quad, so we recruited a couple of editors, McEwen and Watson from Lakehead University in Thunder Bay, Ontario, of all places. And they took that over and proceeded at that particular point. It was during the Goddard conference that a group of people decided that they really wanted to have an organization for APL inside of ACM, and a set of some 25, 35 signatures was gathered together, and I was given that set of signatures to take to ACM and ask if we could become a part of ACM. I took it down, and Jean Sammet herself turned us down. And subsequently, there's a longer tale for which we have no time this morning at that particular point in time. And suffice it to say that eventually cooler heads did prevail by the time we got to 72 and 73, that we actually had established by that time originally a group called Staple, which was the SIGPlan Technical Committee on APL, and then later it became SIG-APL when they actually created it. We were the first instance of technical committees inside of SIGPlan. They subsequently created ones for PL1, Fortran, and ADA, but we were the first. And so we pioneered in organizational efforts even there. This content of, in closing, this content of, as Gene McDonald said, of Ken Iverson's habit of writing with one hand and then the other almost got me in trouble, and that's the last story that I want to relate to you this morning. Back in the time frame of the 67, we were getting ready to, I had become so convinced that APL was the only way for Syracuse University to go that in 1968, I wrote a position paper to the administration, and the director of the computing center, Otway Pardee, who's here today, was going to be coming for a meeting where we were going to be presenting to the vice president of the university that we ought to go buy some additional hardware, and we ought to establish it. Only we would buy the hardware on the condition we got APL 360. It had not yet been released. Otway's furnace broke down on that cold Syracuse day, and I ended up presenting to the vice president, and I thought the whole thing is lost after I finished the presentation. A few days later, Otway went into his office and said, "Here's my order for the equipment." Now, in those days, you could order equipment for 90 days, and you had 90 days to cancel the order with no penalty, but if it standed longer than 90 days, it was an order. And it turned out that spring in there, our chancellor was retiring. The two vice chancellors, each of whom expected to be named chancellor, were both passed over, and they both left the university. And there was no officer to countermand the order. Otway wisely said nothing. By fall, the equipment had been delivered to IBM warehouses, and soon we had the entire IBM branch office at Syracuse University pleading the new chancellor that he had to take the equipment that his institution had ordered. And that's how we got APL. During that period of going from having the single terminal in the Yorktown Heights until we actually had our own system, we did a lot of selling internally. And we did a lot of that by having Ken Iverson come down to make a talk for us. And the first time that he came down, he did the same kind of lecturing that he always has done every time that I've seen it. And this is where I almost got in trouble, is that he was proceeding with this hour-long, 2-hour-long lecture, whatever it was, that was part of a meeting. And we had this break in the middle of it. Now, I want you to sort of visualize this in your mind's eye if you can. We had a break and we headed for the restroom, and next to me is Bill Jones, who subsequently succeeded Otway Part D as a computing center director and was a great supporter of APL. And he and I were at this bank of urinals, if you could picture that. And Bill Jones says to me, "Did you see what he did?" And I said, "No, what did he do?" And he said, "Well, he started writing up there with one hand, and then he shifts and he starts turning toward me." I said, "Don't tell him now." In the hallway, he pointed out to me that Ken was ambidextrous. I hadn't noticed. I'd been watching so intently on what was being written. And he was so taken by that, obviously, that he then subsequently asked Ken to autograph his copy of a programming language in both hands.
Well, I'm sorry, I have to apologize, but this particular 9-inning game is going to go into extra innings, so our sponsors and affiliate stations, please bear with us. There's little I can say that Ken Iverson won't. Ken?
Well, I was about to say that I was relieved to see that Roy's organizing skill had left me with exactly negative 13 minutes. But now that he's declaring extra innings, perhaps I should declare a pause to let those of you who want lunch to leave. Clearly, I can't take time to refute all the misstatements I've heard this morning. But I would like to just make a general warning that, as you probably understand, all oral presentations are highly suspect, if only because people like to be entertaining. And so I would like to suggest that if you really are interested in any of these matters, you really should consult some of the written sources. I have a note here. Well, they're suspect too, but at least they stand still while you can compare them. So I have a note here to mention the forthcoming Systems Journal article, but Aidan has already mentioned that, so I won't spend any more time on it. I will mention things that you're already probably familiar with, the design of APL and the evolution of APL that Falkoff and I wrote years ago. But I'd also like to suggest that you take a look at some of the articles that are cited in there. One of them, of course, is Herb Hellerman's PAT system that's been mentioned. And another one I'd like to mention was an article by Eugene MacDonald. And I think that is interesting if you're interested in the development of the language, primarily because it takes one narrow area, namely the introduction of the vector notation and the negative nonsense, and examines it very carefully. And it's really surprising, and I think was flattering to find out how carefully we proceeded, how carefully and slowly we proceeded even on detailed matters like that. I'd also like to mention another source, which, although also oral, is recorded, and that was the film made by John Clark some years ago at one of the APL conferences. And mentioning that, I'd like to say this one will also be recorded, I understand, thanks to Vin Grinnell. But speaking of Clark, I'm reminded of something you might have seen in Mendonca's museum. There's a thin publication there by Clark in which he lists a co-author, which I've always believed to be fictitious, because it allowed him to use the title Explorations into APL by Lewis and Clark. This deserves more than a titter, but I know that most of you are probably ignorant of American history, but you can look it up. You can look it up when you go home. Well, I said I didn't want to get into refutations, but there were a couple of things I really can't let pass in silence. And one was the comment by Larry Breed. He correctly said that the implementers would eventually do the things that Aidan and I wanted, but the idea that they admitted error is ludicrous. And I'd also like to comment on a couple of things that that Herb Hellerman said. First of all, that I should say that he mentioned one or two contributions he had made to the language itself, and I could think of more to add. But he made a much more significant contribution, in my mind, and that was that he early got enthusiastic about the time sharing, which Gene McDonald and others have spoken a little about. And as usual, I just resisted it completely. But I am a quick study, so that when he finally forced me to try a terminal, I quickly realized it was the best idea I'd had for a long time. Now, to get a little more serious, I'd like to say, I mean, I can tell anecdotes too, but since it is close to lunchtime, let me try to stick to a particular theme that I think is important in looking at the development of APL, and that is the evolution and the way that it evolved. And I'd like to comment on a couple of things that I think have been really very sort of deep sources of the directions that APL has taken, and it really goes back to my time as a graduate student. I didn't think it at the time, but I was fortunate. I didn't think it fortunate at the time, but I was fortunate to have two thesis advisors. And one of them was Howard Aiken, who was a primary influence. And the importance of that was that Aiken, after having designed and developed a series of machines with support from IBM, from the Navy, from the Air Force, had realized that the time had come when industry was sufficiently motivated and sufficiently equipped to do a better job of developing new computers than universities. So while other universities were happily starting new projects, designing and building machines, Aiken was preaching and working on developing a course or a program for teaching people how to design and use machines. So well, matter of fact, he finally, in 1955, then introduced a program which he called Automatic Data Processing, a graduate program. And I was one of 4 of his graduate students who hatched just at the right time to help him man this. And so it was from that I really got to turning my attention to education. So my basic motivation for developing notation was very simple. It was that I began quickly in teaching in topics much broader than the things that I had encountered in mathematics. I began to realize the limitations of the mathematical notation I had been raised on, and started to develop notation as I needed it. And as I turned from topic to topic, as I was forced to do, as Aiken got ideas for new courses, I just developed the notation and tried to use it systematically throughout. So that was the one motivation as a means of clear communication between humans. Now, my second advisor was Leontiev, and he was in economics, and he was one of the people of Aiken's colleagues who had been persuaded to start using computers in their work. And so that when I came along, he had a project which essentially was solving differential equations in connection with his economic models. And the result of that was that in my thesis, I quickly realized that in order to have something flexible enough to do any experimentation with the various methods that might prove useful, I found that the first thing that I had to do was to develop a reasonably useful matrix algebra language. So because of that, I had explicit experience in writing an interpreter. Now, the thing that I think is important about that is that when I came to thinking about language, although I did not undertake to do an interpreter, and in fact we did not undertake to do an interpreter for many years, that I was constantly aware of what was possible in a computer language. So that I did not, and we never did, I think, introduce fanciful things into a language that was unrealistic to interpret. So I think that these were the two sources, was the interest in communication because of having to teach, and the tempering ideas about what was reasonable to do in communicating with a computer. Well, let me just briefly say about in the further evolution of the language. The primary thing that sticks in my mind is the following, that as I said, I had to turn my attention to a variety of different fields, like we introduced a course in operations research and so on, and each time I did that, I would try to use or adapt the notation that I had already developed to use in this course. And after about 3 years, I found that, as you might expect, I did what everybody else did. You add bells and whistles continuously until I began to realize this is a hopeless project. And then I began to get a few insights which were essentially generalizations. As soon as I got the idea of the generalization of which what we now know as reduction and inner product and outer product, I began to realize that I could strip out all kinds of special cases, but this took a very, very lengthy and thorough revision. It's a lot of work to rework something like that. And I might mention that one of the things that I did not rework properly was the business of using a minimum. And that was one of the things that Herb contributed when I went to IBM. He said, why do you make the minimum this complicated? And I explained to him why it was, and then realized that with the new facilities I had, it wasn't necessary. So anyway, what happened was a development motivated by applications. In this case, the application was teaching, and then a very ruthless culling of the material. And this takes many, many cycles to do this. Another time when we got a very serious culling was, of course, at the time when we undertook the implementation. And Aidan can speak to this too, the fact that we really ruthlessly left out all kinds of things, many things which have gotten little attention since. I'll mention come back to one of them a little later, and that was the question of trees, which we simply left out. We were motivated more by things that we saw we absolutely necessarily had to have. And so there was a very thorough culling at that time, partly motivated by the limitations of our input devices, so on. But it really was quite a thorough culling, and I think the language benefited tremendously from this. Now, the sad part of the story is, of course, that success brings paralysis, and as soon as you get an implementation, and you get lots of people depending on your work and using it and so on, it becomes more and more and more difficult. And this has been my experience, is that you soon get to the point where you really can't get anything interesting changed. Even switching companies doesn't seem to help very much. But anyway, that's the way that I view that the evolution. It's important that evolution take place. That there is a very thorough and ongoing culling. Now, I suppose I should conclude with a moral of this, and in a way. As far as long-term evolution is concerned, of course, we don't have to worry about that. Time does cull things ruthlessly, and I'm sure it will go on, and we won't be able to have any effect on it. Or as Peter de Vries says, time wounds all heals. But I do think that we can take the kind of advice that a stock breeder might take from something like this. Namely, he can't expect to control the long-term evolution, what species are going to disappear, but he can control his own flock. And one thing that he knows is that he has to be ruthless in culling as he progresses in his breeding. And this is the one thing that it is impossible to sell to people who are making a living at it. I mean, especially, you're very reluctant to cull your herd in times of drought. Let me conclude, though, with a couple of comments on what I say are the unsung heroes of APL. And essentially it is the people who have promoted it, some of them have been mentioned already, but from people who promote it and the people who use it, because I think that these are key. And let me mention first three fellow IBMers who have passed on, unfortunately. Rainer Kogan, who was probably none of you ever heard of, but he was very helpful, particularly in the early days, in organizing trips to Europe for Aidan and I, and making sure we got in touch with the right people. There was Mike Montalbano, who has been mentioned. He's known, of course, primarily as the APL poet, who gave us the lyrics of Apple Blossom Time. But also, as was mentioned, he did some serious work in introducing APL in teaching in business schools. And then there was Bill Berquist, who again may not be known to very many of you, but the thing that stands out in my mind was that Bill, who remained an IBMer all his life, I think never got an assignment where he was supposed to use APL, but always managed to simply go on happily working at APL, no matter what his assignment. Now that's not that easy to do well, it was easier to do in IBM than it is today, I believe. But now, as far as the users are concerned, I think it's the users, it's the applications that are the only thing that are going to ensure the survival of the language. And one of the things that I think that is not understood or not appreciated is that this is something fairly long-term, and don't expect it to appear on the surface. I believe, well, in fact, I know I could mention many different disciplines where there have been very, very important things going on and being used right now, but nobody, including APLers, know that it's in APL. One of the things that I mentioned is some of the stuff that Steve Jaffe is doing, and I'll mention just to stick to one field in chemistry, and another in chemistry where Donald McIntyre has done some of the underlying work for a very distinguished chemist. And of course, I suppose neither McIntyre nor APL will get the credit for that in our lifetime, but never mind. This is the kind of thing that I think that will make the language survive. The second thing that applications people do to us is ensure the introduction of new ideas. And the one thing that I would stress here, which I believe that Aidan and I stressed right from the beginning, was to be motivated by practical problems, and to always try to talk to people who were doing problems, not to people who were theorizing about wouldn't it be nice to have this or that. And in particular, people who not only tackle problems, but do them in an APL way. In other words, implement them in present APL, no matter how awkward it is, and then you understand clearly and can make a decision about whether or not this should be incorporated in the language as such. And this, I would like to mention David Steinbrook, who has, as I mentioned earlier, I had spent a lot of attention on trees in my 1962 book, but we just ruthlessly left it out. I know that there have been some proposals for trees, most of which I don't understand, but Steinbrook's I think I do, because he's written it in APL. Furthermore, he was motivated by a very practical problem, namely, he is interested in notation for musical composition. So, with that, I will let you go to lunch unless Roy has other ideas. Thanks.
Well, we had planned to have some interaction with the audience here, but given the time and so on, I know I've been feasting on this, but my stomach is nonetheless rumbling. However, if anybody has a question that they think will be illuminating to all of us, we'd be willing to entertain one or two.
Here's an honest man.
Ed?
Yeah. I'd like to mention one machine, because we have the claim that the first...
Ed, people can't hear you, and so if you'd just like to ask a question rather than...
Well, I just want to mention the MCM70, the first portable APL computer in 1973. And then I want to ask about the Stanford and APL connections of Donald Knuth and Niklaus Wirth. Anyone who knows about them?
What? Okay, could everybody hear the comment? The MCM 70, was it? In 1972, a one-line portable APL terminal was probably the first Pardon? A machine, sorry, a standalone machine. And the question was, what was the connection between APL, Stanford, Donald Knuth, and who was Nicklaus Wirth? Larry?
Okay. Before Knuth was at Stanford, he was a kid in short pants at Caltech writing compilers for Burroughs. And it was some of his work with the compiler on the Burroughs 220 that got Roger and me involved in computing in the first place. Claus Wirth was a brand new associate professor in computer science at Stanford in '64. I took his intermediate programming class. He introduced Iverson notation, and this was the first reminder I'd had since Ken's presentation in '62 at a lecture, and I later helped teach that same class with Wirth, and if you go to the APL Museum, you'll see some class notes. The summary of Iverson notation, Mr. Breed, Mr. Wirth.
All right, well, I think we all should go to lunch. Things have been pushed off. Clearly, the SIG APL meeting will be at 12:45 in here. Eat fast. Thank you for coming. And thank everybody here.